Hey guys, so good evening, or good afternoon, or good morning. So in the last tutorial we talked about differentiation and the 5 rules. Okay, so let me just write them down here for a brief recap. So differentiation. Okay, we talked about the 5 rules. Okay, so the first rule we've talked about is the constant rule. Okay, sorry. So constant. So the constant rule actually, what it states is that let's say you have a function of y and you have a equals to a x squared. Okay, so how would you differentiate this function is when you take the derivative of x with respect to y. Okay, the constant will not remain touched. Okay, so it will remain as a, and then the x will be differentiated. Okay, the x squared will be differentiated actually, right, and it would be 2x. Okay, so a times 2x would become 2ax. So that's basically the constant rule. Okay, basically the constant itself that's multiplied, or the coefficient that's multiplied to the x, would actually remain untouched in the differentiation process. The next rule that we're familiar with is the product rule. Okay, the product rule, it states that if you have a function of y expressed in terms of a function fx multiplied with a function of gx, so the derivative of this particular function would be equal to gx times f prime x plus fx times g prime x. Okay, so that's basically the product rule. Then the third rule we have is the quotient rule. Okay, so the quotient rule, let's say we have a function of y in terms of fx over gx. Okay, so the derivative would be dy dx is equals to gx times f prime x minus fx times g prime x over gx squared. Okay, so that's basically the quotient rule. Now we have two more other rules that we've talked about in the earlier video. One of them is being the chain rule. Okay, and the other one is the inverse rule. Okay, so in the first video we've already done examples regarding the constant rule, alright, product rule and quotient rule. Now in this tutorial we'll focus on only the chain rule and the inverse rule, but of course the other rules like constant rule, product rule and quotient will be used, obviously, right, for the differentiation, but we'll put emphasis towards chain rule and inverse rule. Alright, so without further ado, let's start some questions together. Okay, let's erase this real quick. Okay, alright, so our first question, okay, is to differentiate. Okay, so differentiate the function fx, okay, is equals to 4x cubed minus 2x plus 1 to the power of 6. Okay, so we have to differentiate this function, and I will give you guys the time to pause this video and give it a try. Okay, and later I'll come back and obviously try to solve this problem. Okay, so assuming that you guys already paused and tried to attempt this problem, now let's try to do this together. So first we have the function of fx is equals to this, right, 4x cubed minus 2x plus 1 to the power of 6. So what I'm going to do is take this part, 4x cubed minus 2x plus 1, and I will substitute it with a letter u. Okay, so in this case we'll have u as equals to 4x cubed minus 2x plus 1, alright? And we'll of course have the function fx expressed in terms of u. So the derivative of fx with respect to u, okay, sorry, u to the power of 6, my apologies, with respect to u would be 6 u to the power of 5. Whereas if we take the derivative of u with respect to x, so du over dx would be 12x squared minus 2. Okay, so now we want to find f prime x, right? Or dfx over dx. So it's just dfx over du multiply with du over dx. Okay, so of course, as we can see, that we tend to cancel the du terms together. That's how we end up getting dfx over dx, right? Normally if we're dealing with fractions, by the way, but the same thing also applies to here. So we'll just substitute to become 6 u to the power of 5 times with 12x squared minus 2. And now we know that u actually, in terms of x, is this particular function right here, right? U equals to 4x cubed minus 2x plus 1. Okay, so I'll just change it back, so it becomes 6 times 4x cubed minus 2x plus 1 multiplied by 12x squared minus 2. So that's basically the answer, right, when differentiating. So it's not too bad. I think it was relatively a bit easy, right? So we're gonna go for a slightly more interesting question. So let me rub this off. Okay. Okay. So let's go for a second question. So we have to also differentiate fx, okay? Right, so we'll write this question down. So x to the power of 5 plus 2x plus 1 cubed multiplied with 2x squared plus 3x minus 1 to the power of 4. Okay, so again, I'll give you guys the time to pause this video and give it a try on this problem. Okay, so assuming that you guys already paused and tried this video, a problem, so let's try to solve it together. First thing I've noticed is that this fx is actually a product of two functions, right? So this function, I'm going to label it as u, and this function, I'm going to label it as v. Okay, so u is equals to x to the power of 5 plus 2x plus 1 to the power of 3. Okay, and of course we have to utilize chain rule here, so I'm gonna of course take this out. I'm gonna label this as b, for instance, right? So b is just simply x to the power of 5 plus 2x plus 1. So u would be in terms of b cubed. So du over db is equals to 3b squared. Okay, for b, on the other hand, once we take out a derivative to x, so db over dx is equals to 5x to the power of 4 plus 2. Okay, so of course once we do the chain rule together, so in this case we want to find du dx is equals to du over db times with db over dx. db over dx. So once we equate it together, so du over db is just 3b squared times 5x to the power of 4 plus 2. And of course, once we replace b with the original function itself, so it'll be 3x to the power of 5 plus 2x plus 1 squared multiply with 5x to the power of 4 plus 2. Okay, so that's du dx. Alright, it's pretty you know, I would say a bit straightforward, but yeah, that's how we actually end up getting du dx. So I'm gonna have to erase this, by the way. Let me just, I need some space, so let's write it in terms of, okay, so du dx is equals to 3 times 5x to the power of 4 plus 2 multiplied with x to the power of 5 plus 2x plus 1 squared. Okay, that's du dx. And then of course I'm gonna have to erase this. Okay, now let's do the same for v, right? So we know that v is equals to 2x squared plus 3x minus 1 to the power of 4. Again, we're gonna also use a chain rule here, so I'm gonna take this maybe in terms of g. Okay, so g is equals to 2x squared plus 3x minus 1. Therefore, dg dx, this looks like a y, but it's supposed to be g, so it's just simply 4x plus 3. Alright, and of course we'll have v, I need to speak it orange, my apologies. Okay, so v is equals to g to the power of 4, then dv dg is 4g cubed. Okay, so in this case dv dx is dv dg times dg dx, so dg over dx, so in this case that would be 4g cubed multiplied with 4x plus 3. So g cubed would be what? In this case our g is 2x squared plus 3x minus 1 cubed multiplied with 4x plus 3. Okay, so that's our dv dx. So with that being said, let me just erase it out real quick. Okay, because we need some space. So our dv dx is 4 times 4x plus 3, alright, and 2x squared plus 3x minus 1 cubed. Okay, so erase that real quick. Okay, cool. So now going back to original function, since we know it's a product rule, it's a product rule, so that means f prime x is equals to v du dx plus u dv dx. So it's just 2x squared plus 3x minus 1 to the power of 4 times du dx is 5x to the power of 4 plus 2, and we have x to the power of 5 plus 2x plus 1 squared plus u, in this case would be x to the power of 5 plus 2x plus 1 cubed. dv dx would be 4 times 4x plus 3, and we have here 2x squared plus 3x minus 1 cubed. So with that being aside, that would be our final answer. Of course, you can actually simplify it if you like, but since the question doesn't require to simplify, I just want to find a differentiation of it, of course the derivative of it actually. So this is our derivative, right? And if you have noticed, we've actually used two rules, right? The first rule that we have used here is clearly the product rule, okay? And then of course, as we were doing the derivative for u and for v, we use the chain rule, okay? So yeah, sometimes in some differentiation problems we might end up using more than one rule actually to get the derivative of the particular function itself. All right, so without further ado, let's go to the last question. All right, let me just erase this. Okay, great. Okay, let me choose. All right, so the last question actually states that we have the algebraic function. So for example, we have this algebraic function, by the way, right? Function, and this algebraic function is written in this form. So y equals to square root 1 plus x, okay, minus 1 over square root 1 plus x plus 1, okay? And we are aware that x has to be greater than -1, so that's the domain they've given us. So this is like the domain, okay? And it's stated that it is a root, okay, is a root of this equation, okay? So the root of this equation, xy squared minus 2 times 2 plus x, so 2 plus x y plus x is equal to 0, okay? And the question wants us to show that x is equivalent to 4y over y minus 1 squared, okay, and dy dx is equivalent to negative y minus 1 cube over 4 bracket y plus 1, where y is, the modulus of y is less than 1, which obviously, if you were to understand it, it means to say that y can only be between -1 and 1. It's somewhere between -1 and 1. Okay, so I'll give you guys a bit of time to pause and actually try to do two things. The first thing the question wants us to do is to obviously to show, okay, to show that we can get x is 4y over y minus 1 squared, okay, and then to find the derivative of y with respect to x in this particular form. So yeah, these are the two things that the question wants us to do. So I'll let you guys pause the video for a bit and try to give it a go, okay? And this root of the equation is not needed, it's more of like additional info. Alright, just some stuff, cool stuff that's given by the question, by the way. So it's additional info. Okay. Over here, but yeah, okay. Okay, so assuming that you guys already given it a shot or have tried attempting the question, let's solve it together. I'm going to erase all this because I need some space. Alright. Okay, let me just rewrite it again. Okay, so we have the algebraic function y equals to root 1 plus x minus 1 over root 1 plus x plus 1. So let's rearrange it. So I'm gonna of course bring this part of the function, the denominator, to here, right? We're gonna multiply it, so we end up having y equals to y bracket root 1 plus x plus 1 equals to root 1 plus x minus 1. Okay, so then we're going to go to the next step, which would be y times root 1 plus x plus y equals to root 1 plus x minus 1. Alright, then we're going to rearrange a little bit, so it become y root 1 plus x minus root 1 plus x is equals to negative 1 minus y. Okay, then we'll have here y, okay, actually not y, to be honest. Let me erase that. Okay, so we have here root 1 plus x is equals to y minus 1 is equals to negative 1 minus y. Okay, then quite simply we'd have here is root 1 plus x is equals to negative y minus 1 over y minus 1. Right, so I'm gonna need a bit of space, so I'm going to erase this a little bit if you don't mind. Okay, so we're left with that. Now our next step is what? So we'll have here 1 plus x is equals to, we're going to square both sides, so y negative y minus 1 squared over y minus 1 squared. So we'll have here 1 plus x is equivalent to y square. Okay, actually wait, let's a bit too quick, let's just actually go explain the breakdown. So we'll have here negative y minus 1 times negative y minus 1 over y minus 1 times y minus 1. So we have here 1 plus x is equals to y square plus y plus y plus 1 over y square minus y plus 1. So, you know, as we do it, we'll have here 1 plus x is equals to y square plus 2y plus 1 over y square minus 2y plus 1. Okay, so yeah, again, I'm a bit out of space, so I'll have to erase this part a bit, you know. Yeah, I do apologize for a lot of erasing and going back again, but yeah, having a little bit fun with this. So what we'll end up having is that x is equivalent to y square plus 2y plus 1 over y square minus 2y plus 1 minus 1. Okay, and as we go down, so we'd have your x is equals to y square plus 2y plus 1 over y square minus 2y plus 1 minus, okay, so we'll have here y square minus 2y plus 1 over y square minus 2y plus 1. Okay, and then of course, as we solve the problem, we'll end up having what? We will end up having y square minus y square plus 2y plus 2y plus 1 minus 1 over y square minus 2y plus 1. Okay, so x equals to what? 4y over y square minus 2y plus 1. Okay, alright, then we're going to simplify, by the way. So x is equals to 4y over y minus 1 squared. Okay, so basically we have managed to prove the answer, actually, by the way, right? So I've already proved the first part, by the way. Okay, so we already proved it. Hooray. So now the next part of the question wants us to find dy dx. But how? How can we do this? Okay, We will have x in terms of y actually. So the only possible way we can get is dx over dy. Right, that's possible. This is possible. But in order for us to get from dx dy over this, we use the inverse rule. We use the inverse law, or the inverse rule, sorry, not law, my bad. Inverse rule. Okay, meaning to say that dy dx is equals to 1 over dx dy, okay, for inverse functions. All right, so that's basically the inverse rule. All right, only applicable if the functions have an inverse to each other. Only if y equals to inverse exists, okay, for okay, that's the idea itself. Okay, so the first thing we're gonna do is obviously find dx over dy. Okay, so in this case what we're gonna do is obviously find dx over dy, and we know that x is equals to 4y over y minus 1 squared. Okay, so we can see that it's a fraction, so of course we'll have to use the quotient rule in this case. So I'm gonna have to split it in terms of u and in terms of v. Okay, so u equals to 4y. In this case, du over dy is equals to 4. Okay, and let me just erase this real quick. I think we need some space as well. Okay, and v is equals to y minus 1 squared. So you can see that for v we need to actually use the chain rule. So in this case I'm going to of course write it maybe, let's use b. Yeah, okay, so we're going to express v in terms of b, the letter b. Yes, so v equals to b squared, so therefore dv over db, alright, it's equals to 2b, whereas we know that b is just simply y minus 1, so db over dy is equals to 1. So in this case then dv over dy is just using the chain rule, is just dv over db times db over dy. Okay, so in this case it will be 2b times 1, so in this case it will be 2y minus 1. Okay, so now by using the quotient rule we know that dx over dy is equals to v du over dy minus u dv over dy over v squared. So in this case v is what? We already know it's y minus 1 squared. Du dy is 4, so we're going to write here 4 minus u dv dy is times with 2, and then we have y minus 1 over v squared. So v squared is what? Y minus 1. Okay, when you square it becomes to the power of 4. Okay, so with that aside I'm going to erase this part so we can actually try to simplify as much as possible. Okay, so going back again, in this case dx over dy, I'll take out the factor here, y minus 1. Okay, we're going to simplify it, so we're left with 4 bracket y minus 1 minus 8y. Okay, and it's gonna be over y minus 1 to the power of 4. So as we can see here, okay, as I cut it out, we'll end up having y minus 1 cubed. Okay, so therefore dx over dy equals to 4y minus 4 minus 8y over y minus 1 cubed. So dx over dy is equals to negative 4y minus 4 over y minus 1 cube, okay, and dx over dy is equals to negative 4y plus 1 over y minus 1 cube. Okay, so that's dx dy. Now how about dy dx? So I'm going to erase this real quick. Okay, so it'll be easy for us. Okay, so let's let me rewrite this again. So we know that dx dy is just negative 4y plus 1 over y minus 1 cube. Okay, so we know from the inverse law or the inverse rule that dy over dx is just 1 over dx dy. So we just flip the numerator and denominator, we'll end up having y minus 1 cube over negative 4 bracket y plus 1. So just rewrite it again. So we'll end up having negative y minus 1 cube over 4y plus 1. And that's basically our answer. So that's what you're looking for. So we've managed to prove it already. So we've already proved it. Okay. 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 So with that aside, that's the end of this tutorial video. Okay. And for the next tutorial video, we'll obviously cover other functions. For example, we're going to cover on trig functions, exponentials, logarithmic functions, right, and hyperbolic as well. Okay, and also some new functions as well we're going to cover on differentiation, such as parametric and implicit. Okay, so these are the types of functions that we look into more, okay, when differentiating. And later maybe also we'll look into some optimization problems, okay, because this is after all for an engineering course. So therefore there will of course be some problems where you need to, you know, do some optimization, right? So yeah, without further ado, thank you so much for watching this video, and I'll see you guys in the next one.